All right, hi everyone. Welcome to today's webinar session on investigating communication about genomics and health behavior with virtual reality simulation. My name is Mavra Ahmed, and I'm a postdoctoral fellow at University of Toronto. And I'll be moderating this session with Dr. Staiano, who is an assistant professor at Penington Biomedical Research Center. Before I introduce our speaker for today's webinar, just a few housekeeping rules. As you join the webinar, please put yourself on mute. A recorded version of this webinar will be made available as well. And if you have any questions, please post it in the QA forum, which Dr. Staiano will moderate at the end of this session. So now today I'm very excited to present our speaker for today. Dr. Susan Persky is an associate investigator and head of the Communication, Attitudes and Behavior Unit at the National Institutes of Health. Her research draws upon virtual reality and other technologically oriented tools to investigate new genomic knowledge about common health conditions. So thank you, Dr. Persky, for being here today and for giving us this wonderful webinar. And now, without further ado, I'll just turn it over to you to present. Thanks.
Thank you so much. So I am very pleased and very honored to be here to present my work today. This is work that brings together two things that are really emerging research topics and maturing technologies, to talk about them together to address research questions that I think are really critical for health promotion. So we're all very aware that when it comes to common complex health conditions, things like obesity, like diabetes, we don't use genetics and genomics very much in clinical or in public health settings. However, gene discovery, our scientific colleagues working at the bench, their work tends to spur media attention. So we get public attention and public awareness of genomics, even in the absence of having an actual usable genomic technology in this setting. And so we see examples of this in media headlines. So these are a set of real media headlines, headlines of varying quality, we could say, but that relate to genetics and obesity. So it really is our hope that, and actually our expectation, that in the future we will be incorporating genomics in clinical and in public health approaches to address complex health conditions like obesity. But even before that happens, we already have people becoming aware of and potentially even acting on information in this domain. So indeed, if we look at the estimated heritability of some of these conditions and traits, we can kind of see why we might expect to be using genomic information in future clinical and public health settings. So this is just a graph of several heritability estimates that I pulled off SNPedia. And just to show you, I'll be focusing mostly on obesity today. And obesity, the heritability level that has been derived from research, is about as heritable as things like ADHD and height, things that we really tend to think of as largely genetic in origin. So the way that I think about this, the research that I do, really aims to optimize how we communicate about genomics concepts that are related to these common complex health conditions in step with genomic discovery. So as the genomic discovery is happening, and as technologies for genomics start to become more available and start to kind of roll out into clinical settings. So what this will do is to help us kind of hit the ground running, right? So we can communicate about genomics in ways that will allow for the best possible effects of genomic technologies, and make them so that they are actually ready for communication when we translate them into the clinic and into public health. So in particular, I am very interested in how we might best communicate about genomics in order to encourage healthy behaviors. So these are the things that a lot of this group is interested in, things like dietary, physical activity behaviors, so on and so forth. Also to aid in good and informed medical decision-making. And then finally, to look at how we might be able to use genetic information and genetic explanations to actually help to address some of the blame and some of the stigma that can occur and be associated with certain health conditions, obesity and type 2 diabetes among them, that might change as we change the way that we think about the diseases in the light of health behavior that influences them, but also genetic and genomic predisposition that might influence them. And so I look at this also both in clinical and in community settings as well. So to do this work, I lean very heavily on virtual reality. So I use virtual reality-based research methods. What I'm showing you here is some images from the Immersive Virtual Environment Testing Area, which is a technology-oriented behavioral research facility that I direct at the NIH Clinical Center. And so we really specialize in bringing VR, but also other technical applications to bear on research at the intersection of genomics and society. So just to put this in a little bit of context, there's a taxonomy that Fox and colleagues developed several years ago now for the use of VR, virtual reality, in science. And so one way we can think about virtual reality in science is as an object of scientific study. Okay, so we can research VR itself and think about it as a medium. We can think about how we feel when we're in VR. Do we feel very present in what's going on in the VR versus, sort of what's happening outside of VR? We could think about the psychological effects of using VR. My dissertation work was on using VR to play violent video games, for example, looking at the effects of that. Then there's what most of us would be familiar with, and this is the application, the direct application of VR in science and in medicine and health. So this is the creation of training environments or treatment modalities for things like pain management, psychological conditions, and so on. And so the direct use of VR in these contexts. And finally, we have VR as a method to study scientific phenomena. So using VR as a method to administer our experimental stimuli and to measure things. And so this is what I'll be really talking about today. So why, right? So the first question that you should all be asking is, why do we use VR as a research tool? What does it buy us, right? And so I'm going to give you a few reasons here. There are certainly many other reasons why one might want to use VR as a research tool, but it really depends on the context and the goals of a research program that somebody is undertaking. So one of the first major reasons that I focus on VR is because it reduces what we typically see in psychology and in public health as a trade-off between control and realism. So as a social psychologist, I love experimental control. I want all of my studies to have lots and lots of control, but I also want them to feel realistic, right? I also want them to translate to real world situations. And usually that's a trade-off. So either you do it in the lab and it's very controlled, or you do it out in the real world and you sacrifice some control to get that realism. In VR, we can have both, right? So we can completely control absolutely everything that happens in a VR experimental environment. Indeed, we've programmed it to happen that way, but we can put it in a world that looks realistic and has features of the real world. VR also allows us to simulate complex or impossible scenarios. We can put anything we want in VR. We can travel through the human body. We can see somebody's cells the size of a room. We can do whatever it is that we want or need to do. And this can be really useful when we're thinking about abstract scientific concepts, like the kind of concepts we often think about in genetics and genomics. And then we have enhanced behavioral measurement opportunities. So I can measure anything. I can measure body movement quite easily, because when people put on this headset that you see here, we have to know where their head is in space. We have to know what they're looking at any given time in order for the VR to work. So we just kind of grab that data as it's going through the system, and then suddenly we have this great source of behavioral measurement. And then finally, it's portable and distributable. And I'll talk a little bit more about that in a little bit. So one way to give a good example of this is to start with a research study. So that's what we always do when we create a VR environment. We start with our research question. So I'm going to show you some examples of research that I've done over the years to kind of illustrate how and why VR and the kind of research I do work really well together. So for example, one of the research areas I work in is clinical translation of genomics. So how will doctors and patients talk about and use genomics with regard to doctor-patient interactions? So one of the research questions I was really interested in early on was how a patient's body weight would influence medical students' assumptions about the patient and the choices they would make for that patient's care. Okay, so let's say we want to answer this research question. Okay, so the gold standard approach, which we all know, would be to do a randomized control trial, right? To do an experimental trial. Because what we really want to do is we want to isolate the effect of our key variable of the patient's weight on the outcome. So on the assumptions and the recommendations made for her care. So let's say we want to do this in a real clinic. We can do it, but it's quite complex, right? So the medical visit itself is complex. The patient might be coming in for different things and different visits. You know, different patients someone might bring in a relative, someone might not, so on and so forth. Complexity in the patient, him or herself. So a patient obviously is not only his or her weight. There are many other characteristics and traits and all sorts of things that vary from patient to patient. And then when we want to go and look at the data, what we traditionally do in a clinical setting is we record, either audio or video record the visit, and then we would go in and record, we would go in and code what has happened in that visit, which is, you know, very labor intensive. So let's consider then doing this in a VR clinic. So in this case, we have complete control over our visit and our medical environment. Indeed, it is all digital. We have consistent patient characteristics and behavior, and I'll give you a really good example of this in just a minute, but the patient is always the same. Every medical student who interacts with this patient hears the same thing with the same nonverbal behavior and so on. And we have automatic behavioral measurement for a bunch of sort of key variables. So this is the virtual clinic that we have used for our work. This is just a static image of it, but as you can see, you know, we've kind of taken characteristics from a regular clinic room. And this is the study that I did to address that research question I showed you before. So the aim of the study is to explore the effect of, well, the first was to look at the effect of patient body weight on how a medical student makes decisions and treats a patient, but further then to look at how communicating about genetic predisposition for obesity might influence medical students' stigmatization and clinical decision making. So it's kind of twofold in that way. And so in this study, our participants were med students, and they got one of three kinds of information. They got control information about a totally different topic, information about genomics and weight, or information about your sort of standard behavioral information about weight. They then interacted with a virtual patient that you see here on the right, and this patient was completely identical in every way except for her weight, right? So she had the same voice, she said the same things, she had the same nonverbal behavior. So what we're able to do is actually isolate the patient's weight as the only difference that drives differences in behavior. Okay, so we'll look at a little data from this study. The first thing we'll look at is negative stereotyping of the patient. So when we look at our medical students who got the control condition, so they didn't read about weight at all, and they saw our lean version of our patient, we can compare that with those who saw the obese version of the patient. And we can see that there is indeed a lot more negative stereotyping of the obese version of the patient. Those who got the behavioral information and the genetic information, we can see that those who got the genetic information significantly reduced the amount of negative stereotyping of the patient. Now we can look at visual contact with the patient, and this is a proxy for eye contact, which we know is incredibly important clinically. And so when we look at visual contact with the lean version of the patient versus the obese version of the patient, we see that our med students made less eye contact or less visual contact with the obese version of the patient. Those who received information about genomics or genetics and weight, however, showed restored eye contact with that patient. And then finally, we're interested in recommendations for health behavior follow-up. And so what we did here is we asked these med students, you know, here's a list of all kinds of primary care consultations and follow-ups you could give for this patient, and which ones do you choose? So comparing only those who saw the obese version of the patient, so here's those in the control condition and the behavioral information condition, and we see fairly high levels of follow-up recommendations for this weight loss consultations, exercise and diet related recommendations. However, those who got the genetic information show actually quite reduced recommendations for these primary care follow-ups. So this is showing us, this first study is really showing us that genomic information provision can really be this double-edged sword, where it can help out in the interpersonal realm, but it may not be as good in the recommendations realm, you know, if it's taken to mean that these sort of follow-up recommendations may not be useful. Okay, and so now we can look at how we might use VR then to look at the other side of the clinical interaction, to look at the patient side. So another study that we did sort of early on was looking at racial concordance between doctors and patients. So we were interested to see whether racial concordance or racial match between a patient and a doctor influenced African American adults' perception of their cancer risk in response to the information the doctor provided. So we had doctors provide, virtual doctor, and he was either racially concordant or racially discordant. And again, nothing about this provider varied except for the apparent race of the provider. That was the only thing that was different. And that provider gave genomic-based cancer risk information to participants on a series of cancers. And then we were interested in how this would influence their cancer risk perception. And what we found was that receiving risk information from a racially concordant or matched race provider resulted in more accurate perception of lung cancer risk following the visit, holding everything else constant. So changing only the way the provider looked led to differences in perception of risk. Okay, and so now I'll give you another example from the patient side. So here we kind of followed up on this idea of patient race, and we then brought it back into this weight management context where we started. And so here we were interested in seeing how physician-provided genetic information about obesity would influence the patient-physician relationship and the health behavior motivation. So those are kind of the two outcomes that I'm interested in this domain. Now, for a variety of reasons, there's ways that giving genomic information could lead to sort of better or worse outcomes on each of those characteristics in terms of the relationship and in terms of the health behavior motivation. And so what we're also very interested in looking at is what are the moderators? What kinds of factors might tip the balance to cause more positive versus more negative outcomes when communicating about genomics? Because again, we're really looking for ways to optimize that communication. So the two things we looked at here were patient race. So in all cases, our participants were interacting with this provider you see here, this white male provider. And then we also looked at patient incidental emotion. So this emotional state that our participants were in. And we induced them to be in either an anger or a fear state in this study. So here's what we found. And I'll just mention that our participants were 198 women, all of whom were self-identified overweight. So we asked them, how much stigma did you perceive from this virtual provider? And what we found was that our Black participants perceived more stigma from the provider when he provided genomics information than behavioral information, but that pattern was flipped for our white participants, where they perceived more stigma when the provider gave behavioral than genomic information. We also see a very similar pattern for trust. So where our participants who are Black trusted the provider more when he talked about behavioral information, and we saw a flip for our white participants. But potentially even more interestingly, we were able to get a lot of information about what our participants were doing during this visit. And so what this graph shows you is over time, we looked at the interpersonal distance of our participants vis-a-vis the provider. So were they leaning in towards the provider or were they leaning away, which is kind of a measure of engagement and disengagement. And it's just kind of a lot to look at, but basically I'll just point out that this green line here were our Black participants who received genetic information and were in an anger state. Okay, so our Black participants in the self-report measures tended to react more negatively in the face of genetic information, and that's actually exactly what we're seeing here. Okay, so they tend to disengage or move further away from the physician as he's giving genetic information. We see the same pattern among our white participants who receive behavioral information, which again is what we saw to be more negative in the self-report data. So these participants also are moving further away. So they're tending to be more disengaging with that provider. And this is data, again, that we just sort of get based on the virtual reality system operation that we can collect and then analyze. So in all, what we found was that genomic information had a more positive consequence for our white participants, but a more negative consequence for our Black participants who may have been more sensitive to topics and conversations around genomics, potentially especially coming from a white male provider. But we also found that emotion moderates the appearance of this sort of negativity in the nonverbal behavior. So it may be that you sort of have to be in this anger state to start exhibiting some of these nonverbal behaviors associated with the sort of negative interpretation of the information that's being provided. So then in this context of the clinical studies, I'll just point out something from two other studies that we have in the field right now, which is the portability and replication aspects of VR. So VR allows us not only to bring people into the lab and collect data, but we can also go out into the world and collect data from samples that might be difficult to reach. For example, from practicing physicians, right? It's very hard for us to get them to come to us, but it's easier for us to go to the medical center, set up camp, and sort of collect data from them there. We can also collect exact study replications at multiple sites. So we can basically package up our VR world, do our studies here, but also send the very same VR world out to other people in other places, and they can conduct the exact same study. So right now we're in the process of collecting data for a study for medical residents at 6 different US sites that we've traveled out to with our equipment. And we've also sent equipment to California to do a study among nurse practitioners within a nurse practitioner training program. All right, so we'll shift gears a little bit. So that was sort of the clinical side. And now we can think about community translation of genomics. So an example research question that I have in this area is, what is the influence of giving mothers information about their child's obesity risk on food choice behavior? So this is a study my colleagues and I were working on where parent feeding behaviors were the primary outcome that we wanted to measure and address. So how do parents choose to feed their child differently, or do parents choose to feed their child differently after this information is given? So we can look at it in the same way we looked at the clinical environment. So if we wanted to do this sort of in the best possible way, we would do it in a real eating environment, right? We would be in a place where parents would typically choose food and look at what kinds of food the parents were choosing. So maybe we would put them into a buffet environment, right? The issues here, again, are this sort of control versus realism issue. So a buffet restaurant is very uncontrolled, right? It could be that, one day the salad looks amazing and is very attractive, and another day the lettuce is all wilty and it's looking terrible, right? Or there might be different people around you when you're making your choices, which might influence you in different ways, for example. In addition, food choice is notoriously difficult to measure. Approaches for this vary, but it often relies on weighing a plate at the end of the day, trying to separate out different kinds of foods and weigh them and figure out what ends up on this plate. And it's really pretty hard to do. It's also quite expensive and wasteful, which I guess is my last point there, to actually be having parents collect food on plates that ultimately probably never gets served to children, right? It probably just gets thrown out, measured and thrown out. And also, we don't get process measures, which is something we're really interested in. So again, you can videotape and code videotapes of sort of how long did it take them, which foods did they start with, where did they go next, but it's incredibly labor intensive, and there's a lot that is missed by conducting these activities in the real world. So again, we'll compare that with VR. So if we do a virtual reality eating or food serving environment, again, the environment is completely controlled. You can make that participant the only person in the buffet, or you can have other virtual humans in there with them. The measurements of the food are built in and are totally exact. So for example, in the environment I'm about to show you, we know down to the, we know by the cubic centimeter how much of each kind of food has been chosen. And we've worked with dietitians and databases to determine what is the nutritional content of the food that's chosen. And process measures are automatic. We know what people are looking at. We know where they're walking. We know when they've chosen things. We know when they've put things back, which in a VR buffet, that's the only place you can do that. But it turns out that if you give them the option, some people do put food back. And again, it can be used repeatedly at no extra cost and no extra waste once it is developed. So I'm showing you here an image of a VR buffet that we have developed. As you can see here, I'll mention it has been developed to answer this question about serving food to children. So it is a very sort of child-focused, child-friendly buffet where we've chosen food of different nutrient densities and foods that are meant to be appealing and palatable to children. And also really variable. So parents could make, a healthier or a less healthier plate, just kind of depending on, the foods that they choose. So in the end, after a parent has made all these choices, it culminates in a very well-characterized set of food choices that we then translate into nutritional information. So the question you should be asking yourself now is, how do we know that this actually translates to real behavior, right? So we can measure parents' food choices in a VR buffet, but what does that actually mean? So we undertook a validation study of our VR buffet. And I'm showing you here one part of the validation study. We did a bunch of little pieces and parts that we sort of put together into a paper, but our key thing that we did was we took one single food in the buffet. It was actually a training food that we used to train parents on how to use the buffet, which is a pasta with red sauce. And the reason we use this is because you can actually create a whole child meal out of it. Not everyone would say it's a whole meal, but a lot of parents are fine with that, giving the pasta and saying, okay, that's lunch. So what we did was we brought parents into our lab and we had them create a plate of pasta with tomato sauce for their child in VR. We then gave them a distractor task, and then we had them create a plate with real food that our metabolic kitchen had made to be as similar as possible to the VR buffet's food. And then we also counterbalanced, so not everybody did it in the same order. And then we're able to compare how much of the tomato sauce pasta did parents serve to their child in each situation. And what we found was that those two serving sizes correlated quite well. So the serving sizes of the pasta and also of the drink, which in this case was apple juice, were highly correlated. And what we're really interested in here is relative serving patterns. So we run an intervention, we compare groups. What we really want to know is, are people who are low servers in VR, low servers in reality, and people who are high servers in VR, high servers in reality. So the patterns are going to look the same. And what, at the end of the day, the data tell us are that our VR buffet is meaningful with respect to real life outcomes. Okay, so going back to our research question, again, we were looking at what is the influence of giving mothers information that is family health history based, so genomic information about their child's obesity risk on the mother's food choice behavior. And again, we were measuring this on our VR buffet in terms of the calorie content of the foods and of the drinks that parents chose for their child, following the information that they were presented with. So the information took three forms. Their control condition was a food safety control. So this was very much like wash your cutting boards, cook your chicken enough, that kind of information. We also had a behavioral information condition. So that was really about childhood obesity risk broadly for participants. And then finally, we had a condition that was that behavioral risk information plus a family history-based risk assessment specific for that child. And that could look one of two ways. So in the study, I should say all of the mothers who participated in the study, and I don't think I have the N here, but it was about 230, they were all overweight. So this child had at least an increased risk over a child with two lean parents for overweight and obesity later in life. And we used epidemiological data to get at this personalized risk estimate. So if that child had one parent who was overweight, and in all cases that parent would be the mother, because that's how they were recruited, then they would see this. So they would get information saying that their child's risk for obesity at adulthood was increased because that child had one parent who was overweight. And that is in comparison with a child with two lean parents. If the child had parents who were both overweight, they would get this information. So this information is very similar, but it actually shows the risk being more elevated because a child with two parents who are overweight is at even more increased risk of obesity at adulthood. So those mothers who are in this group got one of those two types of information. Okay, so let's look at the outcomes. So again, what we're looking at on our y-axis is the number of calories that were chosen for the child in the lunch feeding session in the buffet. So those in the control group, and we'll see were different from those in the behavioral information only group, but those who got the personalized family history risk information served even fewer calories. Now I'm showing you here the bar for those mothers who got the one parent risk information, right? Those mothers who were the only overweight biological parent of that child. When we look at data from the mothers where there were two overweight biological parents, we actually see the serving calories come right back up, which was really interesting to us because we thought that it might be risk perception that would be driving this effect. So we would give the personalized risk assessment, mothers would feel like their child was at increased risk, and then they would drop the calories to try to mitigate that threat. But in fact, it was the mothers where there was only that one mother only the mother herself who was conferring the risk to the child who really reduced the calories served. So we thought this was really an interesting outcome, and luckily we had collected data on mother's guilt. So how guilty do you feel about the information we just gave you? And if you look at the data here, the legend is a little bit messed up, but basically what we found was that compared to the behavioral information only and the 2-parent overweight group, those mothers who got information suggesting that they alone were the cause of the child's increased risk were the ones who felt the most guilty. Now, ideally, we would then look and try to determine whether it was that guilt that was sort of the motivating factor that led to the differences in feeding. Unfortunately, the way the study was designed, we weren't able to do that. But what we were able to see was that making healthier food choices in the VR buffet was associated with lower levels of guilt. So actually enacting that healthier food choice behavior was able to mitigate some of the guilt that was caused by the intervention information. So this was something that was really interesting to us. So the next idea then, of course, is, well, we should follow up on that and try to see if guilt is a mediator of this effect, which would be interesting but kind of thorny, right? Because do we want to induce negative affect in parents? What is the role? What is our role here, right? So right now we are in the midst of a new study looking at this. Something else that we really wanted to do was to expand beyond mothers. Obviously, fathers play a large role in feeding children and are very important for children's health, but they are very, very rarely included in this kind of work. And so we launched the Parents Take study, where we are evaluating genomic messages on parent feeding behavior and also assessing the role of emotion as a potential mediator of the effect of genomic information on parent feeding. In this study, as I mentioned, it's currently in the field, but we have about 4 people left to collect data from. So I'm at a very sort of nervous and excited state about this study, but hopefully we'll have results for you soon. Our sample will be at the end of the day about 90 mothers and 90 fathers. And what we've done in this study was to look a little bit more and dig deeper into the complexity of the genomic information and try to do a little bit more exploring as to what kind of messages are more effective and less effective, and how can we really optimize those messages for improving child health. So we have our control condition, and here we give parents really general information about exercise, nutrition, and sleep, right? That these are all very important things for child health. One thing I'll point out about this control group is it was really important for us that we touch on nutrition, that we touch on food. Otherwise, we have a lot of problems with the virtual buffet and social desirability, right? I mean, you put a parent into this virtual buffet after you've given them information about childhood obesity and you say, okay, feed your child. You want to make sure that that kind of social desirability effect is consistent across all of your groups, so that anything that kind of happens above and beyond that, you can attribute it to the intervention. So we always make sure in our control group we're talking something about child feeding and child nutrition, right? Then we have a genetics group where we basically talk about genetic effects and how one's genes, sort of broadly, not a single gene, but how one's genetic makeup might influence obesity risk and how this is passed from generation to generation. Then we have a family environment group. So this one is really about the foods that parents keep in their house, whether they eat together, whether physical activity is a part of the family. These kinds of things that are the sort of non-genetic factors that influence children's obesity risk. And then finally, we have our gene family environment interaction. And this is really the way that one's genomics, when their DNA kind of come together with the environment to confer risk upon a child. And this condition is really an attempt to communicate reality, right? The way that this really works, in that genes never affect anything in isolation, nor does family environment affect anything in isolation. But it's kind of a hard concept, right? It's a hard thing to communicate to people and to know how much and what needs to be communicated to have the best effect. So our trial was designed to randomize parents to one of the 4 conditions. We then measured their emotion, including guilt, but also some other candidate emotions that we were interested to look at. We then put them in the virtual buffet to measure the feeding for the child, measure their emotion again, and then we have a 1-week follow-up where we're looking at behavior that's occurred in the interim and also their emotion once again to see whether we have that guilt now is reduced or whether it stays with them, whether we're engendering negative affect for a longer term, and whether we're able to have any effect on feeding sort of outside of the lab environment. So as I said, this is ongoing. I'm hoping to have results in the near term, but you will have to stay tuned and wait for them, just like I will have to. So this is a really good example of what we're doing with using VR as a measure of parent feeding behavior. But as I mentioned, that sort of process behavior that we get as parents are making the food choices is also really important and can tell us some really interesting things. So I'm going to show you a couple more examples of research that we're doing with more of that behavioral data in our VR buffet. So the first is a project with a colleague of mine, Chris Markham, where we have applied relational event modeling to look at the process data as parents are walking around this buffet making food choices. So here, we really wanted to see how the micro processes that make up that ultimate plate that a parent ends up with, how they unfold over time. So relational event modeling essentially answers the question, given all of the things that have happened up until this moment in time, what is the most likely thing to happen next? So when we go in and we look at how events unfold, we're able to do a few things. So we could see effects of the built environment, right? We could see effects of how the food ordering in the environment would influence the choices that parents made. So we were able to see that how things were located next to each other on the buffet was important. We were also able to look at the influence of social norms. So we were able to see what we might typically do in a buffet move from entree to dessert. So we could look at kind of order effects in the buffet. And here we're just seeing the things that we expect to see, which give us even a little more confidence that people's behavior and their behavioral patterns in the VR buffet, are relevant for real life food choice patterns. And then the last thing we were able to do was look at effects of the intervention. So we could look at how people's behavior over time differed based on the intervention condition they were in. And this was based on data from the Mother's Take study, the first study that I showed you with the virtual buffet. So just as an example of what we found, we saw that those parents who got the personalized risk assessment for their child, they exhibited less what we call choice inertia. And choice inertia is just that once you've taken a serving of a food, the most likely thing to happen next is to take another serving of that food, right? So to increase your portion size. So parents who had gotten the personalized risk information for the child were less likely to exhibit choice inertia. And this really exhibits kind of an attention to portion control. So we can see not only that we got intervention effects, but by kind of peering into the black box, we can start to see how those intervention effects actually occurred. And then I'll show you one more example of work that's ongoing. This is a paper that's currently under review that was led by one of my students, Haley Uremich, where we wanted to see what could we tell from using physical body movement, right? We know where people are walking from moment to moment, 2 times a second as they're using the virtual buffet. So we were really interested in what kind of information we could extract from this physical movement. And we used a metric called path tortuosity, which is really just the straightness or the curviness of one's path as they move through space. The image that you can see here is the walking path of one parent as he or she moved around the virtual buffet. And this is one of our more tortuous paths. So it kind of doubles back on itself and there's a lot of kind of moving around. Whereas other parents had kind of a straighter walking path as they were choosing foods. And our hypothesis was that path tortuosity would relate to parents' perceived levels of effort and motivation potentially as they were choosing the foods. So what we found ultimately with path tortuosity was that it was related to post-test guilt about sort of the child's feeding. So basically what we thought was going on here is that parents whose paths were more tortuous, who kind of walked back and forth more, felt like they were trying harder, right? So they felt like they had really made a good effort and thereby felt less guilty after making those feeding decisions. And I'll also say that this correlation held after we controlled for their pretest levels of guilt, the amount of fruit and vegetables and calories. So indeed, actually, after we controlled for what they actually chose, the amount of time they spent choosing it, and so on and so forth. So this work is very, very exploratory, but it starts to show us something about how we can take the behavioral measures and movement that people are enacting in VR and use it to infer things about their psychological and motivational states. So I'll wind up by talking a little bit about limitations. I could talk about limitations on several fronts, but I'm going to focus here on VR. So I'm not meaning at all to suggest that VR is going to be a fantastic tool for all research. There are certainly types of research and types of research questions where VR is much better suited than others. A few of the limitations I will mention include the sort of artificial intelligence and conversational abilities of avatars. So if you remember back to the doctor-patient interaction work, certainly those interactions were very scripted on the part of the avatar. So the avatar said the same thing no matter what a virtual doctor or a virtual patient said, I'm sorry, no matter what a human doctor or a human patient said to that virtual human. Now, in terms of it being a training tool or something else like that, the artificial intelligence aspect is going to be a big hill to climb, and it's going to be really important. But from a research perspective, I actually prefer that every single one of my participants in a study gets the same amount and the same type of information as everybody else. So from my perspective, the scripting is actually a good thing. But for other applications of VR, that's going to be an issue to address. We also have many missing cues. So if we think about the buffet, the studies that I showed you, actually the first study I showed you, there was no smell. There's no haptics, which means like there's no touch. You can't feel the weight of the tray, so on and so forth. So those are missing cues that sort of take away maybe from some of the realism of the VR environment. But again, we did show with our validation study that the environment seems to be real enough that it holds information that's useful for real life. And I'll also say that we are working to adapt smell in some of our current work with the buffet. It's been a little bit of an uphill climb. It's been pretty gross at times, but we're working on it, and as are a lot of other people. Then we have the cost of content development. So as most of you, I'm sure, are aware, the cost of virtual reality hardware has come down and down and down. It's a consumer item. You can get it fairly cheaply. From a research perspective, you can get it very cheaply, but the cost of developing an actual VR world is still very, very high. And so that's definitely a limitation. It's something we think about a lot, and it's a reason why when we develop content, we try very hard to make our content as flexible and as adaptable to other research questions as possible. And then finally, just two sort of more general things about the bringing of VR into this world of health and medicine and science. And the first is privacy and VR data. It's not so much of an issue in the research context, because in the research context, we're bound by all sorts of consents and rules and IRB about what are we going to do with the data, how will the data be stored. But once you move outside of the research context, VR generates a whole lot of data about people. As you saw from our last project with Path Tortuosity, we are starting to be able to figure out psychological states based on those data. And so there's a lot of questions going around right now about what should we be doing to protect and to keep private some of the data having to do with use of VR. And then the last is validation and evaluation of products. And this has some to do with research. There is definitely a lot of research that's done using sort of one-off VR worlds where the worlds aren't validated. The outcomes that are reported aren't necessarily validated to real-world outcomes. And so that's something that I think we're starting to pay a little bit more attention to. And then there's also the issue of VR products for health and medicine. It's now a big booming industry, lots of startups, and the amount of validation that occurs on some of those health and medical VR products is it's not as common as we would like to see. It's a very similar issue to what's happened in health in mobile apps, where there's a lot of variability in content and not as much validation as would be optimal. So a couple of just pieces of food for thought there. So what I'll do now is just kind of wind up. I want to acknowledge my current lab members and my former lab members and all the collaborators who have worked with me on these projects, and then to just go ahead and invite questions.
Thank you, Susan, so much for this presentation. And I wanted to say on behalf of the E&MHealth SIG of ISBNPA, we really appreciate your time today to share with us what's really groundbreaking research in VR, and particularly showing some examples of how VR can be used in many different aspects of scientific research. And so what I'll do now is take some questions from the audience. We already have a couple. And I encourage others, feel free to click that tab at the bottom, the Q&A tab, if you have any other questions for Susan. And so the first couple of questions are pretty concrete questions about people who are interested in maybe starting to use VR, but they don't have much experience doing that. So one question is, what platform or software do you use or recommend to build your VR environment?
Yeah, so that's something that's been changing over time. We started working in VR. So I started working in VR in the year 2000, which used to sound very futuristic, but no longer it does. And so the landscape has changed a lot. Right now, I would say that there, are a few kind of big players. We've been working in Unity most recently, but are also working at, on other projects in sort of other platforms and other languages. And I would say that most people I know of are working in Unity, but some are working in Unreal. And I think it really just has to do with what kind of features your VR system really needs.
And you spoke a bit about the costs and how the costs have come down.
Mm-hmm.
But could you give examples, perhaps for people that have limited funding, of ways that they can get involved with this type of research?
Yeah, absolutely. Mm-hmm. So costs have definitely come down, but to do a comprehensive VR research environment, we're still talking in the tens of thousands of dollars. However, there are a lot of people who have already developed things. So for example, our VR buffet, we are in the midst of having that sort of reported into Unity so that we can make it more readily shareable. So if other people are interested in using that as a measurement device, and they could get it from us and potentially use it or tweak it to serve their needs. In addition, I have a lot of colleagues who've had a lot of luck partnering with computer science departments in their institutions. A lot of computer science students are quite interested, sort of in getting into this space and learning how to program for VR. So that's been really profitable. Unfortunately, I don't have that ability here at my institution, but that's been a really good direction for a lot of my colleagues as well.
Thank you. So the next question is coming from Anda Smith from Ghent. And so in the literature on virtual agents, there's some discussion about how real and human-like the agent needs to be to try to avoid the creepy feeling of recognizing that this is not an actual human. So what would you recommend then on your experience with human agents in VR?
Yeah. So that is something we talk about called the uncanny valley, when a virtual human looks really real, but just not quite real enough. And there's definitely sort of a creepy factor. That's been a really big issue kind of leading up to this point in time, where it was fairly easy to fall into that valley. Now I feel like the people who develop avatars and virtual humans, are sort of well aware of that, and are typically developing in ways that don't kind of strike that chord for a lot of people. So I do worry about it a little bit less. The other thing I'll point out is that some very early research that the group that I was part of in grad school did looked at how real is useful, right? So there's a whole range of looking very cartoony to really photorealistic, and how photorealistic does a virtual human really need to look to achieve, the ends. And some of that early research suggested that it's not so much about how photorealistic the virtual human looks, it's more about how they act. So do they act in a way that is what you would expect? You know, do they blink? Are they responsive to you? You know, are they sort of psychologically realistic in that sense? So sort of depending on what you're looking at as your outcome and what you really want to achieve, you may not need, you know, a virtual human that looks almost perfect. It may be enough. And then other people are certainly using video, so like rotoscope videos of people in VR to great effect. And so of course those people look completely real because they are videos. So there's a lot of range of ways to achieve that without having problems with this sort of creepiness or this uncanny valley effect.
Thank you.
Mm-hmm.
So Susan, what potential do you see for combining VR with other real-time measurements? So whether it's physiological measurement or measuring emotions or perceptions.
Yeah, I think there's a lot of potential for combining VR with these other approaches. So VR and physiology have been combined for a really long time. Actually, one of the first projects I did looked at galvanic skin resistance and EKG and some other cardiac measures in response to a violent virtual reality video game. So that's something that we've been doing for quite a long time, and it seems to work well. So that's been great, and you can get a lot of information about your users' sort of experience and state by doing physiology, certainly. Eye tracking is getting to be more and more achievable. There are announcements about sort of some of the major VR manufacturers are starting to come out with eye tracking integrated systems. So that's a big direction that people are going in. Emotion tracking, I think that's a goal for a lot of people. I think, you know, the goal of a lot of these startups and a lot of companies is really to get as much information about people as they can to try to predict behavior, maybe even to influence behavior. Some of it starts to get a little a little Black Mirror and a little bit dystopian, but I definitely think the aim of most people who are developing for VR, thinking towards the future, is to combine it with a lot of other peripherals and a lot of other things to understand more about the user and also to give a more sort of realistic experience.
One of our attendees asked, what's the rationale for using virtual reality and not using augmented reality? So
in a lot of the work that I do in particular, I really want to control everything. Like, I want to completely create the experimental environment. It's not so much that I want to put experimental content into a real world environment. And if I did, I certainly would want to use augmented reality or AR. And several of my colleagues do that in more of the sort of medical training spaces and in other in other kinds of research and other kinds of development. But for me, you know, as an experimental psychologist, what's so powerful is that I get to sort of create the entire environment and control absolutely everything. So for me, I don't particularly want to introduce, you know, the variability that you might get by using augmented reality into my work. Although I'm always thinking about and always have an eye towards situations where it might be appropriate and, you know, might make sense for us to kind of head in that direction.
I'll use executive privilege to ask my own question. What role do you see for VR in physical activity promotion, particularly as it might relate to limitations related to motion sickness and external equipment and all these sorts of areas?
Yeah, so VR and physical activity is actually a really burgeoning area. It's something that a lot of companies have taken on. And there are a lot of people developing specific VR tools to go with, say, like exercise bikes. So there are companies that have VR displays hooked up to exercise bikes where you control yourself in a game based on your actual physical activity and your motion. Motion sickness can be an issue, but there are so many different permutations of these VR physical activity environments that it's not always an issue. It's more of an issue if your view is moving without you moving. And so, you know, I think it's an issue, but I think you can get around it with some of the different ways that people are combining VR and physical activity. Another thing that we've been seeing is that some of the VR games that weren't necessarily meant as a physical activity intervention that involve physical activity are really motivating, and people want to play them, and so you get physical activity. So there's a game called Beat Saber that is insanely popular in the world of VR, where you're essentially sort of moving around to music and dodging things and trying to slice things with these sabers. It's really fun. If you ever have the opportunity to try it. But really, I mean, it's so motivating that people are getting physical activity without meaning or wanting to, right? And so I think it's this kind of, this edge of like, can we make it so fun that that people will do it and not be so focused on the fact that they are getting physical activity. The things that are an issue have more to do with heat and condensation with the head-mounted displays. And I know some people are working on displays that have little fans in them and sort of other ways of dealing with it, but sweating while wearing a head-mounted display is not fun. And so I think, you know, people are working on it. I'm sure it won't be a problem for long, but those are really more of the issues now, in addition to cost as well. And I do know that some gyms are starting to bring in VR systems as well. So, you know, do you do it at home? Do you do it at the gym? I think it's all going to depend on how the technology is going to roll out.
Thank you. So we have time for 1 or 2 more questions. If anyone has a burning question, please add it to our Q&A. One of our attendees asked specifically about your comments on missing cues.
Mm-hmm.
So, you know, have studies quantified the effect of missing cues in the environment and then the potential bias that this might cause?
Yeah, so missing cues are always something we think about as we're developing, and we tend to develop in spaces where we don't think it's going to be so much of a problem. So, for example, with my buffet, we are very specifically looking at parents choosing food for children. We're not looking at people choosing food for themselves, because we think it's probably more of a problem when you think about choosing food for yourself, because it's probably not as cognitive. You're probably it's not as much like, oh, this smells amazing, so I'm going to take it. You know, it's not as much about, you know, this looks fantastic today. So we try to stay away from things where we think that those missing cues are going to be a really big problem. Now, that said, we're really working on the smell and sort of adding that into the environment. And that's something that a lot of other people are working on as well. It's hard to get smell right, especially with things like food. So it's going to be tricky, but that's a place where we're actively working. Haptics are really hard because it's hard to introduce weight onto a virtual tray. It may be that people do use that as a cue in terms of how much food do I have, but we're hoping that they're able to kind of work with all of the other cues in the environment, you know, specifically the visual cues, to kind of show them how much food that they have, that they're not going to, you know, they're not going to do something radically different because that cue is missing. But it is something we always think about as we're developing things. And it is something we can also study, right? And so some people are starting to study what is the role of scent. Does it matter? Does it not matter? And that research is all ongoing, and it's really interesting.
Thank you. Well, Susan, thank you again for sharing your time with us. I know I've learned a lot, and I appreciate the Q&A as well, the discussion. Thank you to Mavra, Ahmed, for organizing this for us, and then of course for the E&MHealth SIG with ISBNPA. And so we hope that you have a good day or evening, regardless what time zone you're in. And we hope to see you at the ISBNPA conference and catch you at our next webinar.
Thank you very much.
Bye.